Hello students, welcome to my channel. Today's topic is how to measure the size of a molecule, and we will take the example of oleic acid. Till now we have learned that by using the parallax method we can measure the astronomical distances. That means distances which are very large. For example, the distance of moon from earth. Now how to measure the smaller distances? For example, the size of a molecule. So in this case, we will take the example of an oleic acid molecule. To understand the concept, let us assume that we form a very thin layer of oleic acid molecules. So to form the thin layer of molecules of the oleic acid, we will drop it into a solution. So let us understand it. So let us understand the concept first. This is the tray and we have a solution, suppose some solution, water solution. We have put some solution in the tray. We drop the oleic acid to the top of this solution so that it forms a very thin layer. So this thin layer is so thin that it is called monolayer. So monolayer means film consisting of single molecules. This is one molecule. This is second molecule, so we don't have any other molecule on top of these molecules. So this is a monolayer, means thin layer forming of thin film forming of single molecules. So the view is side view now. This is, if this is a tray and this is top of the film and we are looking at the molecules from the side. So if we are looking at the molecules from the side, if this is the thickness of the film which is formed, and because this film is consisting of single molecules, so that means the thickness of the film is equal to the diameter of the molecule. As you can see, thickness of the film is equal to diameter of the molecule because this film is consisting of single molecules. There are no other molecules on top of this. So this means if we find the thickness of the film, we can find the diameter of the molecule. So now how to find the thickness of the film? If we know the volume of the thin film, let us say that the volume of the thin film is V. If we know V, then we can find the value of T, which is thickness of the film. Now what is volume of the film? Volume of the film is equal to, if this film is, if the total area of the film is in the form of sphere, in the form of a circle, and there are so many molecules within this film, these molecules, then volume of the film will be area of the film multiplied by thickness of the film. So area of the film will be pi d square into T. Now volume of the film we know, it is known. Let us say that we have already measured it and its value is x. So that means we know pi d square into T, volume of the film, is equal to x, which is known. And from here we can calculate T. T is equal to x by pi d square, where d is the diameter of the thin film, this thin film. So this is D, so this we'll measure. When we drop it on the tray, we will measure the diameter of the thin film. So the diameter of the thin film can be measured. X is already measured, we know it. And from this formula, T can be calculated. T is equal to X, which is V, is equal to V divided by pi d square. Now let us understand how do we do the experiment to measure the molecular size of oleic acid. In the first step, we form a solution of oleic acid in alcohol. This is the first step. In the first step, we form a solution in which we take oleic acid in alcohol. So we take 1 centimeter cube of oleic acid and we add into it alcohol so that the total volume becomes 20 centimeter cube. So we take 1 centimeter cube of oleic acid and we add alcohol in this, so that the total solution becomes, volume of the total solution becomes 20 centimeter cube. And then we take 1 centimeter cube of this solution again. Then we again take the 1 centimeter cube of this solution, and then further add alcohol in this 1 centimeter cube of this solution, so that again the total volume becomes 20 centimeter cube. So now by doing this in 2 steps, we have got a very dilute solution of oleic acid in alcohol, and its concentration can be written as, concentration of this solution is 120. This means 1 part oleic acid and total volume was 20 into 1 by 20 centimeter cube of oleic acid per centimeter cube of this solution. So this is the first step. Now in the second step, we lightly sprinkle a lycopodium powder. We take lycopodium powder and sprinkle this powder on the surface of a water which we take in a tray. Right? So we take some water in the tray. And then we sprinkle this powder on top of this water surface. Now why do we sprinkle lycopodium powder on the water surface? Because if we directly put this solution of folic acid onto the water surface, it cannot be seen by naked eye because it's transparent. But if we sprinkle lycopodium powder on the water surface, then after that if we put this solution on the layer of the lycopodium powder, then this becomes visible. This thin film becomes visible. The idea is to form thin film of this solution onto the water. But since we cannot see this thin film when we directly put it on the top of the water surface, put lycopodium powder first on the top of the water surface, and after that we pour this solution onto the surface of the lycopodium powder. So this is the second step. So in the third step, after we have put this lycopodium powder on the water surface, so in the first step we prepared the solution. In the second step, we took water in a tray, and on top of the water surface we put lycopodium powder. We sprinkle lycopodium powder on the top of the water surface. In the third step, we start dropping this solution, that's the solution we prepared. We start dropping this solution drop by drop onto this lycopodium powder and water solution. So suppose we drop n number of drops. N is the number of drops of this solution. Suppose we pour n number of drops of this solution on the surface of lycopodium powder, and let us assume that V is the volume of each drop. Then total volume of the n drops in the solution is equal to n into V, centimeter cube, right? If V is the volume of each drop and we have dropped n number of drops, then total volume of the solution that we have dropped on this tray is NV. Clear up to this point? Now when we pour this solution onto the layer of lycopodium powder, it spreads, and once it spreads, it forms a monolayer of oleic acid in alcohol. Now some of the alcohol dissolves in water and some of the alcohol evaporates. So what remains is the thin film of oleic acid onto the lycopodium powder. Now we know that volume of n drops of solution is n into V centimeter cube, and amount of oleic acid in this solution is NV 1 by 20 into 1 by 20 centimeter cube. right? This is the total volume of oleic acid in the solution, because we took this solution in alcohol and the concentration of oleic acid in alcohol was 120 into 120. So if total volume of oleic acid is N into V, then the volume of oleic acid becomes N into V into 1 by 20 into 1 by 20 centimeter cube. Now this is the total volume of oleic acid in alcohol. So we know this total volume and we know the area, and area of the film from the diameter we can calculate. So when we calculated the thickness of the thin film with this method, the size of the oleic acid molecules came out to be 10 raised to power minus 9 meters. So this is the molecular size of the oleic acid, which is also the thickness of this thin film. So that is all for today, students. Take care. Hope to see you in the next lecture. Bye bye.